Hi everyone. So my paper I did was OASIS, or Prioritizing Static Analysis Warnings for Android Apps Based on App User Reviews. This was a textual analysis category paper. This is from 2017 from the ESECFSE conference with three authors. And the problem that they were working on is how do you prioritize lint warnings from your static analysis tool? Um, and how do you actually do this when you're aiming to improve code quality? There are many studies in the past that have looked at historical data in deciding which static code analysis warning should be fixed first. But many of those studies prioritize the warnings based on categories of prior code changes or regression models of those changes. And that's really a problem when you have new changes that do not really have past data, or you don't have a lot of past data. And there's always unique issues with new challenges or new implementations. So the author's goal is to present a new approach to prioritizing those warnings based that you get from your static code analysis tool. And kind of the problem statement that they present here made me think about the classic quote from the stock market that past performance is no guarantee of future results. And what they really focused on is Android Lint, which is a comment analysis tool in different Android apps. And they presented that many different code bases can have thousands of these warnings. And here I just wanted to show an example of an Android Studio project with a few hundred warnings and how they're presented. It's not necessarily the easiest thing to see, and one way that the developers in the different studies that they reference are trying to prioritize these is actually just by suppressing different types of warnings. But that's a problematic approach if those different classes eventually actually have problems in the future. And they're just suppressed. You won't actually be able to see them ever. So other approaches are to prioritize them based on the warning level. There are different warning levels. So there's warning, error, info, and there's different like hierarchy of those warnings. And here's an example of a warning from that they present in the paper that's actually a warning category. And sometimes you could just try to prioritize these by the warning level, but this is not necessarily a good approach because it doesn't actually show whether or not this has an impact to the user. So why is this problem important, prioritizing the static code analysis warnings, is because code quality is very important to the user at the end of the day. It's very user facing. If they find an issue if a end user finds an issue, it's not fixed, they can easily find another workaround or another app to use, which could cause you a loss of revenue if you're developing this app to try and make money. And if the app handles any secure information, the warnings could be used to indicate the issues. And if you don't prioritize the ones that are actually causing security vulnerabilities, uh, then you really would have a problem with how you treat your users' data. So the other kind of issues is what on the term topic of how much time do the developers actually use prioritizing this. So many developers can search in these warnings and prioritize them. And that's a big waste of time for them to be handling the issues that really matter. And also, Android development is very fast. It may be not feasible for them to look at previous warnings and try to decide which ones to fix. And to illustrate this point, the authors put together this screenshot of different examples from user reviews from the Play Store. And here's a great one that really shows what they're talking about. Instant upload doesn't work in Nougat. That's the only reason they bought the app. And I mean, that just shows you that if you don't prioritize these warnings that can show you eventually that the apps have issues, you might lose your customers. So what are they proposing in their proposed solution here with the OASIS tool? They're basically trying to show a blended approach to prioritizing the warnings. And they want to prioritize not based on past data, but based on app user reviews from the Play Store. And this leads to the acronym OASIS, or Prioritize Warnings Based on User Reviews. And their goal here is to combine the program analysis, so static code tool, and natural language processing techniques to try and link those warnings back to the app user reviews. And one of the challenges there is that app reviews are noisy and each user explains problems in their own way. So they try to measure similarity between the reviews in order to figure out which topics really matter. And we'll dive deep into that. So this is the structure of the tool, OASIS tool. It's a layered approach where the word semantics are what they're trying to integrate between the warnings and their users' reviews. And the output of this whole thing, just as the quick takeaway, is they're trying to give an output of ranked warnings. So what are the most important warnings? And which ones have the most possibility to have an impact to user functions? And so they're doing a three-step solution to solve the challenge, which is warning transformation or augmentation, the user review filtering and prioritization, and then they are doing a warning document and user review pre-processing, where they're trying to extract more useful information. And we'll dive deep into that here. So the first step is the warning transformation and augmentation process. So here they're creating what they call a document, which is the warning document. And the goal of this warning document is to give more context to the warning, to the lit warning, such as the category, summary, potential problems, and the user environment, which would be impacted. And then OASIS is doing more things to try and actually get more context from that info, from that warning. So here's an example of what they did. They get statements around the code location. So they're finding the important information about the function and code context that's relevant to this lint. And then they're also identifying in the call hierarchy where this fits in. So it shows the flow down of the function calls, which is very important for debugging. And then they're also finding the Android components which are actually impacted, such as broadcast receivers, which can be very user-facing and show you exactly where in the user experience does this lint warning have an impact. So this is mainly the goal here, is to actually get more contextual information about the lint warnings. And in step two, they're filtering and trying to get better prioritization of the app user reviews themselves. So they're trying to remove noise from the app user reviews because they note that there's a lot of noise in app user reviews. So they're using a tool called Surf, which filters reviews into different categories. And they only really want the one called problem discovery. And Surf on its output would give you many different categories like information giving, seeking, future request, and problem discovery. And so it makes sense that they want problem discovery because they're trying to find app user reviews that discovers an issue and they're telling people about that in their review. So they're going to prioritize the reviews that have higher weight using equation 1. So equation 1 is if your review is low, so 1-star review, if you look at Play Store, they're going to normalize this back to a high score in their equation 1 here. So equation 1 says if for any given review system, so if we have 10-star, 1-star, 5-star, right, this normalizes it to where low reviews get a high impact to their priority. Then the next thing they do is that they take a higher weight to new reviews. So if we have a new review, that means it's more likely to show problems in the current state of the app. And then what they do is they take the product of these two things, which is their output final review rating. So if it's new and it has a very bad score by the user, then that's a very important review to consider. Now, if we move on to what they're doing next, which is this warning document and user review pre-processing. So this is the section where they have a lot of different things being done at once. So they are trying to actually extract useful tokens or semantics from the information here. So they're breaking up the data into smaller words. They're removing stop words like the and if. They're bringing words back to the base case. So means like if you had uploading, it would just become upload. And to do this, they're using the Stanford NLP library, and they're also using a method called the term frequency inverse document frequency, or TF-IDF. And this is what they're using to filter out words which may not be actually important, such as phone or app, which comes up in a lot of reviews and have no meaningful uh, impact to what the actual terms that they're talking about in their app reviews or in their warnings. So by removing all those generic terms, you end up with more rare and meaningful terms that would carry a lot of weight. And so now, after we've got that set of words that have a lot of weight, then we are going to prioritize with this, the semantics aware methodology. And basically, the authors give a single line goal here, which is to say that a warning should be ranked at a higher place if its described issue can cause problems complained in a lot of app user reviews. So if that warning links back to a lot of app user reviews, that should be really important. That's the whole goal. And what to do this, they use a tool called Microsoft Concept Graph, which here I found it's an open source on GitHub, and it's quite old, but the paper is too, so it makes sense. And this tool, the Microsoft Concept Graph, is going to better understand the text, and it's going to have going to highlight the concept similarity between the user reviews and the warnings. And the authors proposed two different methods to compare against their Microsoft Concept Graph method, which is Jacquard and cosine similarity, which are kind of the standard data mining approaches, which we actually learned about last semester, which kind of show you basically similarity between items. So now that we went through all these different steps, let's just review again where they are in this layered approach. So you've got your input, you have your lit warnings and your app reviews here on the left and right. And then from there, the warnings get transformed and augmented, which is the creation of that warning document that gives that contextual information. Then we do the filtering and prioritization with the surf tool in order to get those app reviews, which have the goal of delivering information. Then we're going to do that whole warning document and user review pre-processing with the stop we're removing and the TF-IDF to find the most important words. Then they're going to flow that into their semantics aware warning prioritizer, which tells you which warnings and app user reviews would be the most important and have the most similarity. So we end up with a ranked warning list of which warnings have the highest chance of being real based on the app user reviews. And so when we look at the results, we have basically a set of 6 different apps. And the apps are compared against those 2 baselines, which are the Jacquard and cosine similarities. And then the other one is just ranking the warnings against the project's lint warning severity settings. So does this actually come up as a high priority item in the project-specific lint settings? And so basically to do this, they also had the 6 different apps had a different numbering of reviews, categories, and downloads. And we can see that here. So different number of downloads, we had a different number of warnings, different number of views, and across different categories. So they tried to be diverse with their selection of the 6 apps that they used for the analysis. And so they labeled the issues the lint warnings basically to find the ground truth. So they did this manually. So they found 400 warnings per apps based on looking at the warning, searching what the issue was, and then testing the app to find out if these were real ground truth issues, if these were real issues that caused user impact. And so they selected a total of 248 unique warnings that were found to cause user issues, which were the basis of the true positives for the whole experiment. And then to compare all of the methods, so especially the concept against the Jacquard and cosine, they use precision at n, which reports the percentage of positive warnings among the top n. So n you can choose. So in the top 10, which ones were real issues? That's basically what this is saying. So if you choose 10, in the top 10, how many are real warnings that cause user issues? So basically, we see that OASIS is performing very well at low end. So in the top in a number of results, how well did OASIS find real issues? And it's outperforming in 4 out of the 6 cases. So the only one where it really didn't show any improvement at all was CGeo, which was an app where the users already were using a lint analysis and they had strong desire to eliminate lint warnings before the app went into production. And we saw no improvement from the concept or any either cosine or Jacquard here. And that makes sense because if they're already eliminating all the lint warnings, well, there's nothing that we can see because most of the warnings are gone already. So the conclusion and effectiveness of their concept is that it performed well on 4 out of the 6 apps. Canine Mail was another one that I didn't mention in the previous slide, but Canine Mail did not have an OASIS outperform in most of the cases due to many common keywords. So most of the app reviews were complaining about networking issues. So there's nothing to link that back to the lint warnings because this is probably mainly networking issues when you set up the tool because it's a mail app. And then the other takeaway that the authors had was if there's some sort of coincidental keyword matching back to the code or the warnings, then OASIS will kind of link those together. And just by coincidence, it will try to flag something and it won't perform well there. And then the challenge is so Google Play does not tell you what version that the user reviewed. So you just kind of have to guess what the what version of the program they were reviewing. So maybe that review was on an older version, which already had something patched or a newer version. So it's hard to know which version of code to compare the warnings to. And then also OASIS was also implemented only with Android Lint and does not support any other common tools which are used. And OASIS basically was only tested on a certain number of user reviews and a certain number of downloads. So small number of views, they didn't test the tool at all, so they don't know how it performed. And then basically, as I mentioned before, they only did 6 apps total. So they only had 6 total apps to compare against. And this is probably because of the total amount of time due to the manual research that they were doing. And then also the last one is if you already consider lint in your development process and you already have a very low number of lint warnings, then the approach is not effective at all. So the future work that they propose is integrating more contextual information, such as comments in the code. And then the other thing, which is obvious, is because they only did 6 apps, they would prefer to, in the future, analyze a larger breadth of apps and a higher number of apps to really prove out the tool more. So thank you. I appreciate your time, and please let me know if you have any questions.